All right, join me for the math on the spot video. You're going to need scratch paper, so if you don't have some, now's the time to pause your video and go get it, and then you can join us. All right, let's begin.
You know, it's great that we can reach such fantastic heights thinking about statistics. And actually, that reminds me of a wonderful riddle involving the heights of a basketball team. And this is going to be totally unrealistic, but it actually makes an interesting point and illustrates a really important statistic concept. Let's take a look at it for ourselves and have some fun just fooling around with the old basketball. Let's check it out. Now, let's suppose that all the members on a basketball team had the exact same height. Now that, of course, is very silly, but just for the purpose of argument, let's suppose they all have the same height. Let's see how we could explain and use reasoning to find the mean absolute deviation of the players' heights. Okay, well, first of all, what exactly is the mean absolute deviation of anything? Well, here's what that means. It basically means the distance away all the values are from the mean, and then we're going to find the mean of that. So let's think about it. The mean, remember, is that balance point if you have a bunch of numerical data. Now, once you find that mean, some of the data points might actually be over the mean or under the mean, right? Well, if we look at the distance away each datum is from the mean, then that's a particular value. And if we take all those distances and find the mean of those distances, which basically means add up all those distances and divide by the number of distances we computed, then that is exactly the mean absolute deviation. In some sense, it tells you how far the data actually deviates from that balanced mean, if you will. Now, let's think about this silly scenario where we have a basketball team where every player has the same height. If every player has the same height, do we know the mean? We absolutely do. Because if we're computing the mean of the same number, then think about it. If I have the same number and I count them, let's say 12 times, and I divide by 12, that's going to give me that same number back. So, if we have a bunch of numbers and they're all the same value, and we find their mean, the answer will always be that the mean is equal to that original same number that we saw repeated. So, that means with all these equally tall basketball players, the mean is going to be exactly their heights, because their heights are all the same. Now, so what's the deviation between an individual basketball player's height and that mean? Well, the mean is the same thing as their height, and so the difference between that number and itself would be 0. So in each case, the deviation of each player from that mean is going to be 0. So 0, 0, 0, 0, 0, 0 for every single basketball player. Well, what is the mean of a data set that looks like just all zeros? Well, you add up all the zeros and you divide by how many zeros you have, and that will, of course, give you 0. So the mean absolute deviation of the players' heights without doing any more work is going to be 0 because all the players had the same height. That's silly. 0. 0 is actually the exact score that I would get playing against this team on an actual basketball court. But on a mathematical basketball court, things are a little bit different. Check it out. You ready? They call me Swoosh Burger. Check it out. You ready? And whoop, 2 points. Whoop, 4 points. Whoop, 6 points. Whoop, 8 points. Whoop, 10 points. Whoop, 12 points. I think you get the idea. Point is that when you think about the mean absolute deviation, it's somehow measuring the average of how far each particular datum is from that balanced mean. All you have to do is add up the individual distances from the mean value to each data point, and then take the mean of those distances, add up all those distances, and divide by the total number of distances, and that will give you the mean absolute deviation. Voila! Have fun thinking about the mean absolute deviations in your life, and hoping that you will, in fact, just get air and hit no rim. See you at the next video. Have fun with math.
All right, thanks for watching, and I'll see you on the next one.